Okay, so in this chapter 5, magnetism and matter, we will study and learn about what is magnetism and what is matter. This is the simple introduction video. This will be the start about what is magnet, how does magnet perform, and all the things. So this chapter is also linked to chapter 4, which is all about which is also about moving charges and magnetism. But it is better to learn the magnetism and matter chapter before going to that chapter 4, because this has all the introduction part of magnet. How does magnet perform, what is magnet, how do the field lines of the magnet are, what are those lines, and all that. And this chapter has just this small derivation, this part where it is comparing bar magnet to equivalent solenoid, and maybe to this torque, dipole moment, or the torque. Other all is just about theory portion. And this electrostatic analog, this is basically they are just giving an analogy, which is the like they are comparing between the electric field and magnetic field. And after that, this small thing about Gauss law. This is very easy. Gauss law. Gauss law is basically the amount of field lines passing through the surface, a closed surface. That's it about it. And then it's all about theory. What about Earth magnetism? How is Earth magnetism? How we compare about Earth magnetism? How was Earth magnetism formed? About its shape, how the field lines go from north to south, from south to north, and yeah, about properties of magnet, like there are three kinds of magnet which are there, and about what is permanent magnet and electromagnets, and about this magnetism and magnetic intensity. This also will be fine. This is basically about how much amount of magnet, the power of magnet is the intensity of the magnet, or the power of the magnet. This also will be fine. So first we'll start with the introduction of this chapter. So in the introduction it says about how was magnet formed, like how is magnet, the properties of magnet, what was the use of magnet, how did they discover magnet. And in the first line they just say that magnetic phenomena are universal in nature, means they are never ending, they continue forever. Even for a small particle or for a big particle, like for an electron or even for an entire universe, there exists a magnetic field. There is no particle which does not experience magnetic field. So this is the one difference between magnetism and electro studies, like about electricity. The electric field, which are the fields from electricity or the current, these go, or these start from positive and they end at negative. But whereas magnetism, they start at north, they end at south, but they still continue the cycle. Like this electric fields, they stop at a time, like not stop, like they end, or they just stop, like they don't influence the whole part. Like example, this is entire universe. If I keep an electric object, or like a electric charge over here, and like then this surface will only get electric field, but this won't get. But if I keep one magnet over here, even a small magnet, like one small magnet, if I keep in this corner, okay, then even this part of the book will experience the magnetic field. That's what it means by magnetic phenomena are universal in nature. They are of vast distinct galaxies, the tiny invisible atoms, human and beast, and all are permitted through it. And this is all about magnet, that everyone experiences magnet. And then over here in this paragraph, it says about the story of magnet, how it was formed, who found it, how it was formed, how it was observed, what were the observations, how did the people used it after that, and everything about that. So first, introduction, chapter 5, magnetism and matter. Okay, magnetism and matter. First, it's introduction. So in this start, it says that for the finding of like for the discovery of magnet, or like magnet ores, or like how they actually thought that magnets were. So around 600 BC, about 600 years before Christ, they were shepherds like people, like cattle people. These people were uh, habitated on one island called Magnesia, and it was in Greece. Okay, so shepherds in 600 BC living in one island named Magnesia, Magnesia, which was in Greece. They come under Greece, and it's an island. Okay, they live in Greece, and it's an island. So what happened was, these shepherds, they wore wooden shoes, but with iron nails. Like the iron nails, they probably used it to tuck the shoe, or like to arrange the shoe, or like give it a design, or in such that order. So what they noticed, that while they were walking around this island, like in this island, okay, one main thing about this is, in this island there were huge deposit of these iron objects, or magnesia. Okay, this island was highly influenced of the magnetic field. Okay, about this magnetic field we can write, like okay, wait, I'll say about this later. Okay, about magnetic field. So this island had too much of magnetic field, so whenever these people would wear wooden shoes and with iron nails, whenever they would walk, they noticed that these shoes would stick to the ground, and the amazing thing was that the shoes with iron nails, those were the ones that stick a lot, not with the wooden shoes, but with the iron nails, with the iron tipped rods. Like, so that was the first time they know that something there was different in iron. Okay, and that it was attracting. What was it attracting? So that island was made of many magnesium ores, iron ores, so it was probably attracting those iron nails with that ore, so it was probably sticking it, that's why. So this was the first encounter with our magnet. So a similar observation, okay, was formed when magnet, like then they discovered magnet. Like, what is magnet? Like, they knew that magnet would attract and repel. Like, they found the iron ore, and they took an iron nail and all. So whenever they had magnet, so whenever they suspended, like, example, this is a rope and this is a magnet. Whenever they suspended a magnet in air, like if I suspend this pencil like this, okay, like this, suspended it like this, and they would always notice that the magnet always pointed in north-south direction. That is, how Earth has North Pole and South Pole, right? So this is Earth, this is North Pole, South Pole. So if I suspend one magnet over here, this point will, then this will point south, this will point north, and if I point it here, this will point south, this will point north. And now, why south, why north? Because south attract, north south react, but if I put over here, it will repel. Okay, it will repel. About magnets, this is a bar magnet. Okay, one magnet, this is north, this is south. Okay, so these magnets, they are like metal or iron rods. So when another magnet is brought into the plane, like, or close together, like example, this is another magnet. Okay, so how like charges repel in electricity, and like charges attract. Like, if this is plus and this is plus, we know, right, they repel. and if this is one electron, this is one electron, we know they repel, right? Same way, if this both are north north, they repel. Okay, they repel. But if I bring one north and one south like this, they attract. Same way, whenever this is painted this, they always align in such a manner, okay, that the south will always be at one side and north will be at the other side. Like look, south is at this side only, and this is the north south. So this is what they mean in north south direction. And they did the same thing. This is they did in air, okay, this they did in air, but they also did in water. If this is a water and they place one rod like this rod also, if this side was north and this side was south, imagine like this part of the earth is north and this part of the earth is south, this would again this be south and this be north. It was a natural phenomena, okay. So these were discovered by the Chinese. These were the people in Greece, the shepherds, and these discoveries were made by Chinese people, okay. And they used this technology that the north will always attract to the south side and south will always attract the north side, so the south will always point at the north. They used during their ship transport or the ship adventures. So they always used this magnet because they were high in technology. They used this magnet to guide their ship towards their adventure and to their destination. So by learning or knowing about this, there's one Chinese legend which says that one emperor also used this same technology that south will always point towards north and north will always point towards south. So like now you have a fixed path, like look, if this is your south, even if I'm here, I put a magnet, this will always be south. If I'm here, always be south. If I'm here also it will be south, right? South, they always point towards north. So what this emperor did, he made one structure or one object like a material with which he used this magnet, and he used to guide his army people towards the fog. Like example, this is one tower, okay, he has to capture this, and then there is fog everywhere, okay. Then how will they know? How will these people know where they're going? So what happened was these people, they would have magnets, okay, and then this is north, then they will check with that magnet, and if this points towards the north, then they will know that okay fine, this is our destination, we'll go here and we will attack the castle. So over here the word, okay, now the word magnet, on this island Magnesia, what happened on this island Magnesia? They were shepherds around 600 BC ago. What happened? They had wooden shoes and they had iron nails, right? So on this they found this effect, right? This effect, shoes with iron nails, they stick to the ground. So this iron nails had some property. This property they named it as magnetism. And because it was found in the island Magnesia, so from this name they derived this name from the island Magnesia. So the word magnet or magnetism or magnet, same thing, is derived from the name of the island Greece called Magnesia, where the magnetic ore deposits were found. Look, I said you right over here that there was something in this island which created magnetic field. What was this? It had magnetic ores. These magnetic ores attracted these iron nails. Now you get the logic. These iron nails were attracted because of magnetic ore, because there was a huge amount of magnetic ore deposited on this island Magnesia. Because of that, the iron nails were sticking to it. So this phenomena, they call it as magnetism or magnet, were found as early as 600 BC ago. Shepherds on this island complained that their wooden shoes at times stayed stuck to the ground. Their iron tipped rods were similarly affected. This attractive property of magnets made it difficult for them to move. Okay, this is point number 1. This is important. Okay, this was for the introduction how the magnetism was found. And then the second was the direction property of magnets were also known since ancient times. So we think that the people found it about magnets now. No, but it was since long time, because people would always use iron nails. You know how common is iron nails. So they knew how to use iron. They knew how to use the technology. So a thin long piece of magnet, when suspended in free air, freely pointed in the north-south direction. Always north-south direction. Always. So if this will always point about north-south direction. Always. Okay. And the name design thing. Okay, this technology was exploitation of this property is generally credited to Chinese text during 400 BC mentioned the use of magnetic needles for navigation on ships, caravans, and crossing Gobi Desert employed magnetic needles. So they used this magnetic property. What property? That they suspended freely pointing in north-south direction. They used this property to guide or navigate the ship's canvas crossing about 400 years ago. Okay, and then this is the third story about it. A Chinese legend narrates the stale victory of the Emperor Hyung Ti about 400 years ago. About 400 years ago means not too far also. About 400 years ago, which he owned to his craftsmen. These and okay, so this which he owned to his craftsmen, means to his people, to the people who crafted for him, to work for him. These are basically called engineers also. These engineers built a chariot on which they placed a magnetic figure with arms stretched out. So what happened was, you know what is a chariot? Chariot is what? Chariot is like if you have one animal like these. If you have one animal, and you know they have like a bullock cart. So what they have was, on a bullock cart, they made that one person, like they made a statue of a person. Like you see this is a statue of a person. This is a bullock cart. If you see, this is a cart. Okay, this is a cart and this is a bullock cart. You can also search in Google about chariot, you'll get it. So what this was, this man would always point his one arm. His one arm would always stretch. This will always point towards the south. Okay, so the figure swirled around so that the finger of the statuette means the statue on this chariot on it always pointed to south. With this chariot, the Hang Ti's troops were able to attack the enemy from the rear in thick fog and to defeat them. Okay, so this is very famous because they used this very technology to attack the enemy and win the war and defeat them. What he did, he had a bullock cart, and like kind of a bullock cart, and one person with one arm stretched was placed on it. So what he did was, one of the arm was stretched out, and this always would align to south. Why would this be aligned? What do you think? I just said you. What if this is made of iron? Okay, we know iron is freely suspended in air, so it will point in north direction, right? So this is north, this is south. So it's pointing in north direction, right? So it will always point towards south. So wherever I move this object, it will always point towards south. Example, this is south, this is north. This is pointing like this. What if I move this over here? Still pointing this side. What if I move it like this? Still pointing this side. What if I move it like this? It will still point towards here. Okay, so this is what happened, and this is about just a random thing. You don't have to worry about it. And then some of the commonly known ideas regarding magnetism. So this is the properties of magnets. Okay, so Earth behaves as a magnet. Point number 1. This is important. Okay, Earth behaves as a magnet with the magnetic field pointing approximately from geographic south to north. This I'll tell you about it later. So, but what we have to understand is that this is Earth, and this Earth behaves like a magnet also. Okay, and it points from south to north. So this is south, this is north. Okay, no, okay, field. Wait. And the field lines from south to north. So from south to north. Okay, from south to north. Then second point, when the bar magnet is freely suspended, it points towards north-south direction, which you know it. The tip which points to the graphical north is called the north pole, and the tip which points towards graphical south is called south pole. So if this is a magnet, if this is pointing towards the north pole, then this is called geographic north. Or if this is pointing towards the geographic north, then this is called north pole. And if this is pointing towards the geographical south, then this is called south pole. Okay, so example, this is Earth. Again, we have our very own Earth. Okay, if I place one magnet over here, okay, if I call this as north and this is south, the south is pointing towards south, so this is called south pole, and north is pointing towards north, this is called north pole. Okay, now there is a repulsive force when north poles of two magnets are brought together. Conversely, there is an attractive force between north pole of one magnet and south pole of other magnet. So basically, like charges attract, no, like charges repel, and unlike charges attract. They attract, they repel. Okay, this third point. Fourth point, okay, this is an important property of magnet. Okay, example, this is a magnet, south, north. If I break this, still this will be south, this will be north. Okay, I'll give you an example. Okay, so what I mean is, example, this is one magnet. Okay, this is north, this is south. What if I break it from here? Now you'll be like, this is north, this is south, right? But no, this is the unique property of magnets. This never happens. Now you'll be like, what happens? This will still be south, this will still be north. Means magnet having one pole can never exist. They will always have two poles. Look, above from here, I know this is south, so this will definitely be north. I know this is south, so this will definitely be south. So this is the property. We cannot isolate the north or south pole of a magnet. If bar magnet is broken into half, we still get similar bar magnets with somewhat weaker properties. And of course, the magnet became from this to this. Of course, it will lose some power. Example, this is one pencil. If I break this pencil, it will become this much, and then I can only use this much pencil, whereas I could have used this much. And therefore, their monopoles do not exist. And fifth property is we can make magnets from iron and alloy. That's it. And then there's this experiment on bar magnet, how we found about bar magnet. I mean, this is just not much anything of it, and yeah, that's it. Wait, let me and yeah, one thing I'll just make it now clear about field lines. And you know, this is a magnet. This is important, okay? I mean, you probably know about it, but I just didn't mention about it. This is north, this is south. They always make field lines, magnetic field lines. What is magnetic field lines? See, I mean, you're checking at these diagrams. So what it means is, like, if this is a magnet, there always are field lines. You know how for charges, if this is plus charge, this is minus charge. They go like this, right? I mean, like, they go like this, right? Same way, if this is north, this is south, there are field lines. Okay, there are field lines. Okay, like this, field lines. They emerge from north, and they start from north and they end at south. Okay, they start at north and they end at south, like this. You see, they started north and they ended south. And now you'll be like, I just said over here that they are never ending. Over here I said, right, that they are never ending, they become forever, like they are still universe. But inside this magnet, these lines are still running. These lines are still running. So can you see now? This is in this structure, like this. Are they still stopped? No, they still running. This is the thing about magnetic field. They never stop, and they form closed loops. They formed closed loop. Magnetic field. So this is called magnetic field. This phenomena is called magnetic field. They formed They form closed loops, never ending, start from north and at south, but they still go within it. Okay, this is for the theory part we are saying about this. Okay, and main thing is, you'll be like, if this is magnet, how will I know that this is field lines? I can't see. These magnetic field lines are imaginary lines. Okay, we cannot see it, but because of the experiments we know these are like this. Okay, so to prove this experiment, we have this bar magnetic experiment. Okay, this I will take in the next class. So thank you so much.